and additional 90, which means that 450 degrees. It's done. Next would be radius 10. Can you say which is the radius 10? Radius 10 is here. Radius 10. We have maintained the smaller radius also and larger radius 70 mm, the outermost portion. We have maintained the outermost portion of radius 2. Now let's have a look at again regarding the Archimedean spiral. First of all, you will have these three data. You need to have a degree of the rotation, smaller radius and the larger radius. Draw two concentric circle. First would be larger radius circle, that is 70 mm, and smaller radius circle, that is 10 mm. Now after you draw these two circles, divide those circles into 12 equal parts, which means that 30 degrees each. Give the nomenclature to the same, 0 to 12. Now we need to draw a Archimedean spiral for the 450 degrees. So that's why we have deducted 450 from 360, which comes around 90 degrees. So we require additional 90 degrees. That's why we have put the 3 points, 13 on 390, 14 on 420 and 15 on 450. Now after this portion has been completed, we have divided these line into 15 equal parts. The line distance is 60 mm. If you want to divide 60 mm line into 15 equal part, which comes around 4 mm. We have taken 4 mm each division and mark the point with 1 to 15. Now let's consider this C1 as our center, C1 to 1 as radius, continuous arc till first line, and so on. C1 to 6, line till 6, C1 to 12, a full circle, C1 to 13, which means that only 30 degrees additional, C1 to 14, only 60 degrees additional, and C1 to 15 would be directly the outermost point over here. Now from the continuous arc we have got the several points. We have joined these points and we have got our Archimedean spiral. We will give the nomenclature to this also so that it has been clarified. P1, P2, P3, P4, P5, till P15. Give the dimension also. Radius 70, radius 10. This is how you can draw your Archimedean spiral. I hope you have understand the whole method. Now we have got the next problem. The next problem is about constructing an ellipse. We need to construct an ellipse using concentric circle method. Over here major axis has been given as 160 mm and minor axis has been given as 100 mm. So let's write the given data first of all. We'll write down the given data first of all. In the given data, Major axis is 160 mm and minor axis is 100 mm. These are the given data. Major axis has been given as 160 mm and minor axis has been given as 100 mm. We need to draw this using concentric circle method. I hope you know the meaning of the concentric circles. We have just seen in the Archimedean spiral. Two circles having the same center are called as concentric circle. Now, first of all, let's consider that this major axis defines the diameter and the minor axis defines again the diameter. So we need to divide into 2 to get our radius. So first circle radius would be 80 mm as the major axis has been given as 160. Taking 80 mm radius, first of all, let's mark a point. (80 mm) radius circle. First of all, we are having the same center and drawing the circle of radius 50 mm. Radius 50 mm. Inner circle is of 50 mm. We have got these two circles which are concentric. Their center is same. Now we need to divide this circle into 12 equal parts. 12 equal parts. Division would be 30 degrees each. First of all, let's draw a horizontal line. Draw very light lines. First of all, horizontal line. Put up protector like this. Draw the angles 30, 60, 90, 120, 150. Again on this side also. 30, 60, 90, 120, 150 and 180. Joining them with very thin lines. Please note that all the point and all the lines would be passing through the center point C1 like this. This is how you can divide a circle into 12 equal parts. Now, as we have divided this circle into 12 equal parts, Let's give the nomenclature to the same. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and again 12. Outer circle is our major axis circle, inner circle is our minor axis circle. So from the major axis circle we will draw vertical lines like this. From the major axis circle we will draw vertical lines like this. Drawn vertical lines like this. Now from this minor axis circle we will draw horizontal lines which will intersect with the vertical lines. Draw the horizontal lines from the minor axis circle which will intersect with the vertical lines drawn using major axis circle. We have got these points by the intersection. We have got this much points by the intersection. Now as we need to follow the minor axis and major axis also, we will consider those points too. We have got all the points which we need to draw by French curve. These are the points which we have got. Now we need to join them using the French curve. Join using French curve to get a very smooth curve. Joining with very smooth curve on the another side also. You can draw manually also or by this French curve also. This is how you can draw an ellipse using concentric circle method. Give the nomenclature to the same: P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11 and P12. We have got both our requirement fulfilled. We have got this minor axis as 100 mm and this major axis as 160 mm. We have got this minor axis and major axis both. Now let's have a look at it once again. We have been given data that we need to draw a ellipse using concentric circle method. Its major axis is 160 mm, minor axis is 100 mm. Now in the starting we have first of all mark a point on the answer sheet. Now major axis has been given as 160, so we have taken radius of 80 mm for the outer circle, and for the inner circle we have taken the radius of 50 mm. Now we have divided those two circles into 12 equal parts, which means that 30 degrees division on each side. We have got 1 to 12 points on the periphery. Now from the major axis circle I have drawn vertical lines. From the minor axis circle I have got the horizontal lines. Where these both lines got intersected, I have marked the point. Likewise over here I have marked the point as P1, then P2, P3, P4, P5. Somebody will be wondering that why I have marked P3 and P9, P6 and P12 over here. We need to take into consideration to the major axis and minor axis also. We have got P2, but we need to maintain that minor axis, so we have got the two outermost portion of this circle. Same way, to maintain the major axis we have taken the two outermost portions of the outer circle. Don't forget to give the dimension and the nomenclature. Join that point with the smooth curve and you can get your desired ellipse using concentric circle method.